Hello, everyone. Thank you for joining us today. My name is Austin Weiser, marketing intern and soon-to-be market and pricing analyst for Cayman's commercial team. I would like to welcome you all to Cayman's second Spotlight webinar of 2018. Today's Spotlight is titled Kaolin Clay for Polymer Applications, along with the introduction of our updated polymer brochure. Today's Spotlight will be conducted by Josh Mathis, who is the Technical Service Manager for Cayman's industrial business in the Americas, serving in that role since 2012. Josh has a Bachelor's of Science degree in chemistry from the University of Louisville and has more than 15 years of experience in research and development and technical service, focusing on coatings, ink, and other industrial applications. If you happen to have a question on your screen, and we'll get to as many as time allows at the end of the webinar. For those questions we do not get to today, Josh will respond to those questions after the webinar via email. Without further ado, I'll turn it over to Josh for today's presentation.
All right, thanks, Austin, for the introduction, and thank you to everyone out there for your participation this morning. We know that you have a limited amount of time, so we appreciate that you are spending some of that time with Cayman this morning, where you are in the world. As Kaolin for polymeric applications, we're going to be introducing some sales tools for Kaolin, for our Kaolin products in rubber and plastics applications. Today we're going to introduce a new brochure that we've prepared, and we're also going to be talking about a total of 11 technical bulletins that will be supplied along with the new rubber and plastics brochure. We're going to focus on 3 of those today. The first being a bulletin on Nylok 171, specifically for polyamide compounds, a technical bulletin on Kaolin versus talc, and a third one on partial replacement of carbon black with polyfill HG. So here you see the cover of the new rubber and plastics brochure that we're going to be issuing. You notice a little bit of difference between this one and our previous rubber brochure. We've traded the black color for the white of the Kaolin. So hopefully this will be a very attractive printed brochure for you to use as a sales tool for your customers. On the inside of the brochure, we have a product selection guide, a lot of the technical data, the typical physical properties of our products, the polyfill products that we recommend for rubber and plastics industry, as well as the treated products. A little bit of verbiage on here as well, describing the various benefits that we expect customers to see when using these products in their rubber and plastics applications. You do set it intentional. This will be a folder that opens, and the center section will contain a pocket that will include the technical brochures that will be issued, the technical bulletins, I should say, that will be issued along with this brochure. And then on the back as well, we have an applications guide recommending various types of products, various categories of products, the calcined clay or the treated hydrous clays for various specific polymeric applications in rubber and plastics. So we have these listed as either recommended to be used. Those are the best recommendations for those specific applications, as well as some that are suitable that may be used in those applications if customers are desiring certain properties. So these are a couple examples of the technical bulletins that, like I said, will be included in the brochure. This is one on wire and cable applications, as well as one specifically for barrier applications. We've tried to update these and prepare these to have more technical data to have application data that will be useful for customers in specific rubber and plastics applications. This is the list of the technical bulletins that we prepared to be included in this brochure. We have several model formulas for rubber in various polymers. We have EPDM, natural rubber, nitrile rubber, as well as the roof sheeting compound, and then some more general brochures as well, like clay extenders and rubber applications, providing some just more general information about the use of our products in specific applications, and the barrier applications, the brochure you saw on the previous slide. Also the wire and cable, the Nylok 171 for polyamide, and also finally the NewCap and Nylok, our silane treated clays specifically for rubber applications. I'm not going to go through all of those in detail today, but we'll focus on 3 of them here that I'll describe a little bit of what you can expect in these technical bulletins that will be issued. So the first one I'm going to talk about is specifically for Nylok 171 for nylon compounds, polyamide compounds. I'll touch on kaolin versus talc in natural rubber, and finally the partial replacement of carbon black with polyfill HG. So first of all, Nylok 171 for polyamide compounds. The challenge with nylon compounds is that they are susceptible to hydrolysis, and that tends to limit the usage of many common mineral fillers. So anhydrous minerals are typically used, among those being calcined kaolin, but untreated calcined clay products have a negative effect on the impact resistance. And here you see the technical bulletin give you an idea of what they're going to look like in the final form. So the solution for the poor impact resistance with calcined clay is to use a silane treated calcined clay like Nylok 171, and that helps to maintain the impact resistance that is lost when incorporating a calcined clay. It also improves the tensile strength, the flexural strength, and the moduli. It increases the heat deflection temperature, reduces kind of a directional strength and anisotropy in injection molded parts filled with glass fiber, and also helps to control shrinkage. Typical usage for Nylok 171, it's typically incorporated at between 30 and 40%. So in this brochure, we've also included an application study where we tested batches of unfilled nylon resin and blended calcined kaolin and treated calcined kaolin at 40% filler loading. These batches were compounded on a 30 millimeter twin screw extruder and then molded, and the physical properties were measured. So these graphs are included in the technical bulletin. You can see how Nylok 171 continues the improvement in tensile strength past what is seen with the untreated calcined kaolin, such as polyfill 70, and recovers much of the lost impact resistance. You see we've gone from about 11 to 12, incorporating the untreated polyfill 70 type into the nylon with regard to the tensile strength, and that improvement is continued to get up around 14 with the Nylok 171. The impact resistance, you can see you've lost about half of the impact resistance incorporating the polyfill 70 type, but you get back almost all of that with the treated, silane treated Nylok 171. So we'll also include a lot of other application data. Here you see we have tensile strength, flexural strength, elongation, impact resistance. All this data will be included on the technical bulletin as well. I'm not going to go into too much detail on these, but just want you to know the types of things that will be available on these technical bulletins. The second one I'll talk about is replacing kaolin with talc in rubber applications. So what are the potential benefits of replacing a talc with one of our kaolin products? We do see a couple of physical property improvements, specifically the flexural fatigue and the tensile strength. There is a potentially lower overall raw material cost for the formulation. Even if you replace at equal volume, since kaolin's specific gravity is 5% lower than talc, even if you're at the same cost, you're saving 5% to fill the same amount of volume with a kaolin as you are with a talc. And that's not even counting the potentially lower raw material cost of the kaolin versus the talc by weight. We do see good extrusion with kaolin. There's a low Mohs hardness, not quite as low as talc, but still very low. So there's not a lot of wear on the extruder. And also, our process makes very pure products that allow long runs without a buildup of impurities on the die tips. This is the model formula that we've used for this study, comparing our polyfill HG and polyfill DL versus what we've called a fine talc and a coarse talc. So you see the particle size for the kaolins is a bit lower than even for the fine talc. By centigraph, we see the polyfill HG around 0.2 microns, the polyfill DL around 1.5, the fine talc just over 2 microns, and the coarse talc that we've used here in this study being 8 microns. And so we've incorporated this mineral filler at 75 parts per 100, and you see the rest of the ingredients there for this particular formulation. Some of the results that we've included in this technical bulletin, we focused on the flex fatigue, the flex cycles to break. You see, especially with the polyfill HG, we're about an order of magnitude higher in flexural fatigue performance versus the coarse talc, and several multiples higher versus the fine talc. So you can really see a lot of long-term durability improvement, especially using an ultra-fine clay such as the polyfill HG. Again, with the tensile strength, it kind of follows the same trend. As the particle size gets smaller, the tensile strength goes up to where we see that both of the kaolin products outperform both of the talc products with regard to the tensile strength. And again, we've included a lot of the application data here, a lot of the cure data that will be available on the technical bulletin to hopefully answer a lot of the questions that your customers may have. You see the cure data, the modulus data, the tensile strength, as well as the elongation on this chart. So the third bulletin I'll focus on will be the partial replacement of carbon black with polyfill HG. We're focusing more on cost savings rather than potential performance improvements. We're looking for, in these examples, similar performance because of the cost savings potential with replacing carbon black with an ultrafine clay such as polyfill HG. We've verified this concept in several polymeric systems. We've looked at it in natural rubber. We've looked at it in nitrile rubber as well as EPDM. And we have technical bulletins, starting point formulations based on all three of those polymers. This is the starting point formula with the polyfill HG and the natural rubber. You see the N660 with the control versus the formulation that includes the polyfill HG. We have replaced 10% of the carbon black on an equal volume basis with the polyfill HG. You'll notice that that adds up to a little bit more weight. Carbon black's a bit less dense than kaolin, so you need to use a little more weight of clay versus carbon black to fill the same volume, but the price difference will be such that there are significant cost savings available here even with the additional weight. So now the results for this test. Again, you see the cure data, the modulus, tensile, elongation, tear strength, and hardness. In this compound, as I said, we replaced 10% of the carbon black with the cheaper polyfill HG, and we see very little change in the performance with regard to these critical properties. So there could be significant cost savings available to your customers replacing carbon black with ultrafine clay without any negative impact on performance. I did want to mention as well, air-floated kaolin clay is commonly used in rubber compounds and is generally sold at quite a discount from our products. So I just wanted to talk about a couple things, a couple of values that we can bring to a customer to justify the higher price of our products versus an air-floated kaolin. The first is the low crystalline silica content. All kaolin products contain less than 0.1% crystalline silica, so no additional hazard labeling is required. It's a natural mineral, so we can never say zero, but it's below that detectable and reportable limit. So as I said, no additional hazard labeling is required, such as it is with an air-floated kaolin clay. The crystalline silica regulations have been getting tighter, especially in the U.S. Over the last year or two. So that may be a good selling point for some of your customers who are concerned about the crystalline silica content. Also, the product consistency we find is higher with our water wash process than it is with an air-floated kaolin process. Our processes ensure low impurity content, and so the processing is consistent over time. The performance is consistent over time with the critical performance parameters. Also, we've heard anecdotally of some processing advantages of using our products versus air-floated kaolin. There could be some throughput advantages in the plants of your customers. So to summarize today, we're excited to introduce this new brochure that details value of our products in rubber and plastics markets, and also we've made available these technical bulletins that describe more specific application benefits for these rubber and plastics markets. These technical bulletins and the brochure are available now in PDF form. You can get those from Austin, put his email on the screen. Those will also be available on the Spotlight portal. And we hope that everybody out there has access to the Spotlight portal and is using it. And if not, let us know and we'll get you a login to get access to that Spotlight portal through our website. So with that, we'll take any questions that are out there. First one, what is the timeline availability for the printed versions of these bulletins? We are looking at the middle of January for having the final versions available in printed form. Like I said, these are available now in PDF form, either by request. If you saw one that you would like to take to a specific customer, just ask us and we can get you an electronic version of that now. But like I said, we're looking at middle of January to have the final printed versions printed and in the hands of our distributors. Also, do you plan to introduce brochures and bulletins for other markets? That's a good question. We have a survey coming up at the end after the webinar is finished. So I'd encourage you to, please let us know how we're doing, and if you have any ideas for ways we can improve these webinars. There's also going to be a question on that survey about future needs. What should we be working on next as far as the literature that we're providing to our distributors. So please take the time to answer those questions for us, so we can make sure that the work we're doing is as valuable as it can be for you, the distributors. So with that, that concludes the webinar for today. Again, like I said, we appreciate your time very much, and please, take the time to answer the survey for us. If you have any additional questions, please get in touch with me or someone else on the Cayman team, and we'll get you the answers that you need. So again, thank you, and have a good day.